aviation radio equipment. The report number 1754. Do we have the presenter?
Hello, dear colleagues. Do you hear me?
Yes, it's good. Can you share the full screen of your slides? F5 button.
In my monitor is full screen.
Try to change the slides. In your monitor, but can you press F5 button? It's already.
I have done.
Okay, let's start. Okay.
Okay, my name is Yulia Petrova. I am from National Aviation University, Kyiv, Ukraine, and I would like to represent the method of service life determined for aviation radio equipment. So the life cycle of aviation radio equipment consists of 4 stages: design, manufacturing, operation, and disposal. The operation is the longest stage, where the functional purposes of aviation radio equipment should be realized, supported, and restored. The duration of operation stage depends on service life or remaining useful life of the equipment and connect with the technical condition, deterioration, occurrence, and wear out beginning. After the end of the established service life, it's necessary to perform evaluation of aviation radio equipment technical condition, which includes procedures for integrity analysis of the all structural elements and reliability analysis. During the estimation process, it's necessary to take into account the non-stationarity behavior of failures and malfunction flow. If the actual level of mean time between failures become less than the level established in operational document for aviation radio equipment, then the decision about possibility of failure operation or dismission should be made. The purpose of the study is to focus on the method of service life determination during radio equipment intended use based on result of aviation radio equipment technical condition evaluation using statistical data on reliability. The serviceable function of radio.
Yulia, I'm sorry to interrupt you, but we cannot see the scroll of the slides. So please, can you disconnect? Not disconnect. Remove your slides, like representation, and then not remove. I mean, turn off the slideshow, and then when you again try to connect it to this Google Meet, use whole your screen. Use the first option, whole your screen. Not just window, but whole your screen, and then choose the screen where it's going to be. And try make it F5.
Oh, it's okay now?
No, we still cannot see. And what is the slide now? The slide number 6?
5.
And we can
now
see
6.
The slide. No, we cannot see the slideshow.
Maybe without full screen?
Try without full screen. Now try to change the position of slides. It's work. Okay, what is the slide on your screen now?
6.
Okay, please continue. I'm sorry.
Okay. So, non-stationarity behavior of failure flow of aviation radio equipment determines the method of data collecting and processing. It's necessary to research of various methods for different models of technical condition deterioration. There are following parameters for estimating efficiency of decision-making while service life determined. It's the probability of correct decision deterioration detection, the probability of erroneous decision, cost associated with the correct or wrong decisions, and time delay for correct decision making. This study concentrates on synthesis and comparative analysis of data processing methods to make decisions on possibility of our equipment operation during equipment intended use. The criteria of efficiency for mentioned method are maximum of the probability of correct deterioration detection and the minimum of time delay for correct decision making. Here's a diagram of synthesizing the method of remaining useful life and service life determining. Using all these parameters, actual technical condition, thresholds, we get the mathematical model of each specified objects and then do conclusion. It may be continuous operation, disposal, or overhaul. Here's the diagram for service life determining. It has two blocks. First, A, its assessment of the actual technical condition of aviation radio equipment, and block B is remaining useful life estimation. In the input, we have technical parameters before operation and history of operation conditional. Then we deal with technical parameters as the service life determining and operating conditional. Then measurements for conducting the survey, evaluating of technical parameters and actual technical condition of the object. The available set of technical parameters that can generate the space of technical parameters of aviation radio equipment depends on the parameters value established in the design stage, on the operating mode of our equipment, and other modes. The technical condition depends on workloads, systematic and random factors. And the change in the technical parameters we can describe by the equation 1. The set of the technical characteristics of aviation radio equipment can be determined based on the results of diagnostic variable measurements. And this process we can describe by the formula 2. The equation 1 and 5 describes the mathematical model of the system for the actual technical condition evaluation and the subsequent service life determining. The considered model can be used for all aviation radio equipment components that have a significant influence on technical condition of whole system. In general, the operator description for all algorithms is similar. The block diagram of the interaction of data processing operators differ in the input data vectors, and these initial data can be represented by the formula 6, where n is the quantity of the failures for each year, and t is the total operating time by year. Consider the main data processing operator. There are the data generation operator for estimating the characteristic of the input parameters vector. Next, the data generator operator for estimating the characteristic of the output parameters vectors. Operator for checking the fulfillment of the given criteria, and the logical multiplication operator. And the input data vector is converted into the more convenient for calculating estimates of output parameters at equation last in this slide, where t is the mean time between the failures. So here we are the diagrams of data processing operator interaction. And the criterion for decision making about aviation radio equipment decommission is the fulfillment of these two conditions. And if the criteria P is equal to 1, in this case, the service life is extended. Otherwise, the service life is not extended. In this work, we consider the 5 different methods for service life determining and then do some calculation. So about this method. The first method, processing is implemented starting from the 0 years from the start of operating until the current moment. This method correspond to the actual method of decision making described in regulation documentation in Ukraine. Other 4 methods use data processing in sliding window, and they are considered second and third part of operating process, and this method differ in additional intervals duration, T1 and T2. To evaluate the effectiveness of the proposed method of several life determining, a computer software was developed that allows to check the correctness of decision making based on the simulation of the failures flow for different intervals of equipment operation. Based on the calculation result, the developed computer software makes it possible to plot the graphics of the probability of decision making about the possibility of aviation radio equipment service to live continuation. Here we represent this calculation only for the first method, and such calculation were carried out for the all 5 method. And then we built these graphics. Its dependence of the probability of service life extending of the start time for increment of different failure rate, and the difference of the probability of service life extending of the increment failure rate for the different start moments. If we analyze this graph, we can see that the minimum values of the function show the 5th method, and we can do conclusion that this method is responds better to the our method. And in conclusion, I can say that the obtained results show that to increase the probability of correct detection of deterioration, it's necessary to make decision about continuation of life service at time moments after observing stationary intervals for aviation radio equipment failure rate model. And this research result can be utilized while designing and improving the decision-making support for operational process of aviation radio equipment. Thank you for your attention.
Thank you very much for your report. It's quite difficult theory of life determining. I remember this from my students' dates and from my students studying. Quite difficult to take into account all the parameters for every piece of the system. So thank you for your report. Dear colleagues, do you have any questions according to this report? Okay, I have one question. Please, Yulia, please tell us in one or two sentences what have you achieved in your report and what is the new result of your report in contrast to the well-known results.
Uh, we synthesize the new method for remaining useful life and service life. This method we can implement in the stage of design and in the stage of operation. And it may be started operation or it also may be implemented later.
Mhm. Okay, thank you very much. So this method is for creation new equipment, but not to investigate the life determinant of already existed. Yes. So this new method can be applied to the new technologies.
Yes,
Okay, thank you very much. This
thank you.
topic is also state of the art for Ukraine because thanks to specialists of life determining theory in Ukraine, we have 90% of destroying missiles, and exactly thanks to non-good specialists in life determining in Russia Federation, we have problem. We have news of rocket failure in the territory of Belgorod. Yes, that's all is connected. Okay, thank you very much. The next report is mine. Please, and the next report is mine, and I have the next three reports, and I. Okay, okay, Ivan, can you see my slides?
Yes, yes.